Greetings and welcome to my new calculus channel. My name is John Gabriel, and I know I've discussed this topic many times before, but honestly, I don't think it can be discussed enough because of its importance and because of the fact that no one I've ever met in my journey or in the many books I've read has ever understood what it means to be a number. So let's talk about this. Thousands of books have been written on the history of number theory, the philosophy of number, etc. All of them are worthless rubbish. That's a big statement. Well, ask yourself, out of all the books you've read, if you have a good understanding of the number concept, and if you can tell me in one line what it means for an object to be a number. So now, one has to look at Euclid's elements to gain an understanding of the number concept. Unfortunately, Euclid failed to do a perfect job. He was almost there, but not quite. So I have completed that which had to be done by clarifying the ideas of the ancient Greeks. Okay? And in my recent, very well-written article, which I will put a link to this presentation so you can go to it, I explain how I discovered the concept of number. And I am far smarter than anyone I know, by the way, people. I really am. And that's not arrogance, it's a fact. I know I'm smart. I mean, I would be dishonest if I said to you that I'm not a genius, because I am a genius. It doesn't mean I know everything, but what I know damn well and better than anyone else. So pay attention to what I'm telling you, okay? I'm trying to enlighten you and to help you understand the number concept. So you can look at another article called How We Got Numbers, which was at one time on LinkedIn, but I got booted off LinkedIn because people didn't like my ideas, and that's a very detailed article on the history of number. So another one is this one here, which is about pi not being a number, and I have had support from several academics, and one in particular who is a mainstream academic sees things the same way as I do. Now, unfortunately, sci.math is about the only place where I'm allowed to comment. I've been banned from every other site because of my ideas, and because mainstream academics are pathologically jealous of me, do not like me personally, and are afraid of what I am doing in my work, namely exposing their incorrect ideas and their inability and their stupidity in not being able to see these things a lot sooner, and hence the reason you're here listening to me, okay? So what I will focus on in this video is just one aspect of the discussion. What does 3 over 4 mean? Okay, first of all, 3 over 4 does not mean 3 divided by 4. It has never meant that. Okay, there is no division pending in the symbol 3 over 4 because 3/4 is a well-formed number. Now, the vinculum, whether it's that forward slash or a horizontal one, means that both 3 and 4 have a common measure or a divisor. In this case, they have the common measure, which is a unit or parts of the unit. In this case, 1 of 4 equal parts measures both 3 and 4. So you start out with the ratio, by the way, 3:4. That's what it means. And 3:4 literally means 3 compared with 4. Or you could draw a line, as you see this red line. I've put spaces there, but there really shouldn't be. I'm doing it so that it looks clearer. So you could compare the length of this line with this line, and then you see if they have a common divisor. In other words, something that measures both of them. And they do, because this little segment here measures both of them, right? So if they do have a common measure or divisor, then you can write this ratio by this number here, which describes its measure, okay? That's right, people. When you go from a ratio to a number, you use the vinculum. How else would you name the number? How else would you name it? There is no, can you give me a better way of naming it? So you're actually naming this distance here, this antecedent, in the ratio that you started out with, okay? So that's what you're doing. So for this reason, you cannot write pi is equal to circumference over diameter, because neither circumference nor diameter have a common measure. So thus you refer to pi as the ratio of circumference to diameter. And note that you cannot think of the antecedent in this case, which is the circumference, as the value of pi, because in geometry there is no ideal unit, and any circle diameter will do. Are you able to grasp this? I am a genius, and at times forget that most people struggle to understand what I say. Let me know if you need help in the comment section, and I'd be glad to help you understand. But please leave your attitude out of the comment, because I have no time for fools. Now, as far as 0.75 goes, it too is a very well-formed number, which is the measure of 3/4 in base 10, okay? So this is how else you would write 3/4 in a radix system. So how many tenths do we need? So we multiply 3/4 by 10 over 10, do this little bit of arithmetic, and we see that we need 7 tenths, okay? We need 7 tenths. 7 times 1 over 10. Then how many hundredths do we need? We need 5 hundredths, and so there's no remainder, and we stop now because the measure is complete. That means 3/4 is equal to 7 tenths plus 5 hundredths, okay? 1/3 has no measure in base 10 because there is always a remainder that has to be measured, okay? So you can't say that it's equal to 3 tenths plus 3 hundredths plus 3 thousandths. It's never equal to 1/3. Okay, never, ever, ever. And it doesn't matter how many n places you go to. I will show you innumerably many other numbers with exactly the same digits in exactly the same n places. So you do not have even a unique representation. Okay, and I'm not even going to talk about the limit theory right now, because that's a bunch of garbage, which I've described many times in other videos. Okay, it doesn't solve the problem of defining number, real, in fact, even something like a real number which doesn't exist, it doesn't solve that problem. And neither do the concuts or Cauchy sequences or any of that bullshit. Now, how many 12ths do we need if we're measuring 3/4 in base 12? Well, we actually need 9 12ths, don't we? Okay, that means 0.9 in base 12. So 3/4 has no measure in base 7. I'm going to leave this to you as an exercise, and you can follow the pattern that I've showed you here before. So for centuries, highly stupid math professors have not understood these things, and there been a proliferation of idiots, such as math teachers, math professors, etc., who have no clue what a radix system means and how it was designed. There are no operators in P over Q, okay? It is a name given to the measure which describes a magnitude P from the ratio P colon Q, which describes this antecedent. P over Q does not mean P divided by Q. It is a well-formed number, okay? And this should be as clear as daylight to my intellectual inferiors, because they talk about that bogus concept called an irrational number. So how can you write circumference over diameter? Because to be a number, both the numerator and denominator in this supposed fraction must be well formed. For otherwise, what on earth does circumference enumerate? What does it enumerate? To be a numerator, it has to be a number, you morons. And I'm sorry, there are some of you who are smart, but a lot of you are not. The mythical equal parts of a diameter, does it enumerate those? What are they? If it's not a number, how the heck can you enumerate it? Don't be a moron. These words, I write, will not be comprehended by most, probably including yourself. But ask me nicely, and I'll try to lower myself to your intellectual level and see if I can produce a modification to educate you better. Now, if you do not understand, or if you do not use this vinculum scheme, then how else would you talk about proper fraction? Okay. you'd have to try to measure it in some radix system. Yes? And in most cases, you will not get an exact measurement because there's a special number theorem that I've talked about in the past, which says that you can only measure P over Q in base B if base B contains all the prime factors of Q. Now, if the fraction is larger than a unit, then we want to know how many units are in its measure. So the obelus operation tells us this. 9 over 4 is equal to this. If we say 9 divided with this obelus here, then it tells us that there are 2 units. 1, 2, because there are 4 equal parts in the unit, 4 equal parts. And this is what is meant by obelus division. So 9 over 4 does not mean 9 divided by 4, and never has. The vinculum is not an operator, but merely a symbol used in the naming process of fractions. This and nothing else. Get it? Okay, so how else would you name fractions if not with a vinculum? In algebra, you cannot perform an obelus division operation with respect to the fraction P over Q, because if P is less than Q, you cannot subtract Q from P. Okay, so in geometry, it is possible to divide any line segment into any n equal parts. Algebra is a weaker form of geometry, a generalization of measure through the abstract unit. Use your brain, people, okay? And if you're not already a subscriber, become one, spread the news of my channel, click like on my videos. I have many enemies, and I think it's worth that you preserve this wonderful knowledge for future generations. Also remember, I am on library.tv or odyssey.com, where you can actually donate Bitcoin to me if you are well off enough, or if you think that you have found knowledge that is exceptional, which if you haven't, then obviously you're a knucklehead, but that doesn't matter. Now, that's pretty much it. I am going to leave you with these thoughts and hope that you will be able to study all these things. I'll put links to all the appropriate articles, etc. My name is John Gabriel, and this is a New Calculus channel. Till next time, goodbye.